Greetings, hello. Welcome to the second example on Thevenin Theorem. Now, the question is given, and as always, we are required to find the load current across the 5 ohm resistor. 5 ohms resistor. Okay. So, as always, first step, draw your Thevenin equivalent or your Thevenin circuit. R Thevenin, V Thevenin, IL, and this is my load resistor, which of course will be this one. I just cut it off from here, then I'll come paste it or attach it to the Thevenin circuit. Alright, cool. So I need to find Thevenin voltage, which is this one here, and my Thevenin resistance. So let's go ahead and find our Thevenin resistance. To find the Thevenin resistance, would look at the source, the type of supply sources, or the type of sources that we have. In this case, we have a voltage source. And for a voltage source, we short circuit, which is exactly what we did here. And then from there, we can just go ahead and reduce all the resistors, combine them into a single resistor, and that resistor is the Thevenin resistance of the circuit, or is our Thevenin resistance, which we are interested in. These two are in series, and together they are parallel to the 22 ohm resistor. So we can get R equivalent, call it 1 over 4 plus 7, that is 11. 4 plus 7 plus 1 over 22. Alright. So give us 1 over 11 plus 1 over 22. What does this give us? It gave me 7.33 ohms. Okay. From there I can then draw the equivalent circuit. These two are combined into R equivalent, which is this one. So it will just be a single resistor that will represent them. It's 10 ohm. This is my 8 ohm. 7.33. Okay. 10 ohms. Okay. From here, you can right away see that these two are in series. So we can, the R equivalent 2 equals to 7.33 plus 8 ohms. And together, they are parallel to the 10 ohm resistor. So 15.33 ohms. Just go ahead and write R equivalent 3. It's gonna be 1 over 15.33 plus 1 over 10. Okay. Gives me 6.052. Make it 3 because it's 526 ohms. Okay. Okay, I can just write down my reduced circuit. It will look something like this. R Thevenin, I'll be measuring from this point. This is my R equivalent 3, which is equals to 6.053 ohms, which is exactly the same thing as R Thevenin at that point. So we have R Thevenin, check. Now we need to get V Thevenin. Let's go ahead and find him. For V Thevenin, we bring back the voltage sources. We bring back the voltage sources. However, we don't touch or we don't bring back the load resistor. That one is gone. We've taken it out. So with the voltage sources returned, let's go ahead and simplify our circuit. This one reduces to an equivalent resistor of 11 ohms. Okay. V Thevenin will be measuring of V Thevenin across those two terminals there. So if that's our V Thevenin, we can already see that it will be the voltage drop across the 10 ohm resistor. It will be the same as that. Okay, go ahead and combine this and draw the reduced circuit. This is 11, 22, and 10. Okay, 210 volts. Okay, from here, from the circuit diagram, okay, what can we do here? Yes, these two, looking at these two, they're in series, these two resistors. So we can also get an equivalent resistor of those. Okay, our equivalent of 8 plus 10, that's 18 ohms. Okay, and I'll write down the I'll draw. So our equivalent is equals to 18 ohms, which is these two combined. One thing that I also want to stress here is Alright, I'll say it now. Let me just do this, then I'll mention that. So that guy there was 11 here, 210 and 22, what else? And 16, 18 I mean. 18, cause yeah, we got 18 there. Once we combine these two resistors, you will see that we lose track of our terminals. We lose track of our terminals because our terminals are across. We are interested in the voltage drop across the 10 ohm resistor, not the combined 10 and 8 ohm. So we lose our terminals here. That's why you don't see it. Okay, cool. But we can observe right away is that this one and that one are in parallel, so you can just combine them into a single equivalent resistor. Let's call it R3. 1 over 22 plus 1 over 18 into the power minus 1. Just go ahead and do this. Plus 1 over 18. Alright, so that gives me an equivalent combined resistor of 9.9 ohms. Okay, I'm gonna redraw the circuit. It's always nice to redraw the circuit so you know where you are. In your circuit analysis, 210 volts, 11 ohms, this is 9.9 ohms. Okay, looking at this, we have two resistors in series, and we know that in series, what happens to voltage? Voltage divides, so the voltage drop across the 9.9 resistor will be different from the voltage drop across the 11 ohm resistor. So it will be different. Okay, so we can use voltage divider to get our voltage drop in the 9.9 resistor, because that's the resistor we're interested in at the moment. Okay, so we would say V 9.9 voltage drop in the 9.9 ohm resistor is equals to the source voltage 210V multiplied by the voltage that we are interested in. This is voltage divider. If it was current divider, we'll be multiplying by the voltage we're not interested in. Now we multiply with the voltage that we're interested in, plus the sum of, not voltage, but the resistance that we're interested in, plus the sum of the two resistors. Two 10 multiplied by 9.9 divided by 9.9 plus 11. That gives me a voltage drop of 99.474 volts. Alright, cool. What this tells me, what does this tell us? What does 99.474 tell us? Well, it's the voltage drop across the 9.9 ohm resistor, but we do not have 9.9 ohm resistor. We do not have a resistor of 9.9 ohm in our original circuit. Instead, we had, or even this one, instead we have 22 ohm and 18 ohm. So the 9.9 ohm resistor is actually a combination of the 22 and 18 ohm the two 22 and 18 ohms resistors. Okay, so that simply tells me that the voltage drop across the 9 ohm resistor the same as the voltage drop there across the 22 ohm resistor, and if it's the same as the 22 ohm resistor voltage drop, tells me that these guys are in parallel, so their voltage drop is the same. Okay, so the voltage drop in the 18 ohm resistor is also 99.47. Okay, that's very important. So V18 is also 99.47 volts. If the voltage drop in the 18 ohm resistor is 99.47, we know that the 18 ohm resistor comes from adding 10 and 8, which are in series with one another. But our point of interest is what? Our voltage drop that we really want is not the combination of 18 and 10. We actually want this one here. So let's just go ahead and get that. Since they are in series, we know the total voltage drop. We can just go ahead and get the voltage drop at the 10 ohm resistor by using voltage divider. So voltage divider, the 10 ohm resistor, the voltage drop across the 10 ohm resistor would be equals to my V18, which is this one there, multiplied by my 10 ohm resistor divided by 10 plus 8 plus my 8 ohm resistor. So that should give me volts multiplied by 10 ohm divided by 10 plus 8. That should give me times 10 divided by 10 plus 8. Okay, that gives me voltage drop of 55.26 volts, which is also my Thevenin. V10 is equal to also equals to my Thevenin. Alright, because I'm measuring Thevenin across the 10 ohm resistor. So what I'll measure with my voltmeter or my multimeter across this terminal XY would be the same voltage drop across the 10 ohm resistor. Another way to think of it, it's as if they are like parallel to one another, so the voltage drop will be the same. Now with all this info, we can complete our circuit, Thevenin circuit. We now have Thevenin, which is 55.26. We got this one, we got what was Thevenin. Or Thevenin was 6.053. 6.053. 6.053. So let's go ahead and now evaluate our load resistor. Remember, we have our Thevenin we have R Thevenin, we have our load resistor. What don't we have? Nothing. So we are good. 0.53 ohms. And this guy was 5 ohms. Load resistor was 5 ohms. IL, and what is this? This was Thevenin voltage, which is 55.26 volts. So what is IL? Current in the circuit. Easy. We can just go ahead and do that. IL is equals to V Thevenin divided by R Thevenin plus R load. 55.26 volts divided by 6.053 plus 5. That gives us our load current of, okay, let's see, 6.053 plus 5 gives me load current of 4.999 amps, which is the same thing as 5.0 amps. Alright, this is probably due to rounding, but that is my answer. Thanks for watching.